Hi, welcome to Provoke Your Physics channel. Today we are going to discuss about the Kirchoff electric rules in an electric circuits. Actually, there are two rules are there. Okay, it is much familiar and it is much important to the electrical students, both 12th as well as the college level. So there are two rules. The one is current rule, another one is voltage rule. The current rule is based on the principle of conservation of electric charge. And the second rule is based on the principle of conservation of energy. So first let us discuss the Kirchoff first rule. According to that, at any junction, in an electrical circuit, at any junction, the algebraic sum of the current is zero. The algebraic sum of current is zero. So let us take in any junction, okay, for example, if I have an electrical circuit, okay, actually electrical circuit is a combination of a battery and some electric components. The components may be a resistor, capacitor, inductor, etc., etc. But it should be a closed one. See, in this closed circuit, suppose if I connected another one resistance and it will be connected here, okay, so I can take this will be the junction. So in that junction, the algebraic sum of the total current is zero. So for example, for my convenience, I have just taken this is a junction in which there is a current which will be moving in that way. Let us take this is I1 and this will be I2 and this will be I3 and this will be I4 and this will be I5. Let us take. Okay, so in this there is a rule that so the current moving towards the junction will be taken as positive, the current moving away from the junction is taken as negative. If it is so, see, I1 is moving in, I2 is moving out, I3 is moving in, I4 is moving in, I5 is also moving in. So I am just taking I1, I already told you the current moving towards the junction is positive, so I1 will be taken as positive. Then I2 is moving away, negative, minus I2. I3 is moving in, so positive. I4 is moving in, so positive. I5 is also moving in, so positive. So the net current is equal to 0. Net current is equal to 0. Okay, so when I am taking this I1 plus I3 plus I4 plus I5 is equal to I2. So from this I come to know one more thing. The total current moving towards the junction is equal to total current moving away from the junction. Yeah. Now we are going to discuss the Kirchoff's second rule. Actually, the first rule will be applicable in the junction, but for the second rule will be applicable to the entire circuit, and especially the circuit must be a closed one. Of course, the electrical circuit will be applicable or will be usable only when it is closed. Okay, it would be studied from your 6th standard itself. See, in here there will be a little more special than the first rule. Okay, what is that? See, in this circuit, if I am moving from A to B, in a circuit, okay, suppose it has a potential E, okay, so here if I am moving from A to B in that circuit, see, I can move from higher potential to the lower potential. So when it is A to B, E will be taken as negative. Similarly, here when I am moving from B to A, if I am moving from B to A, okay, see, I am moving from lower potential to the higher potential, so E will be taken as positive. Now, so it is a combination of current and resistance. Okay, when I am moving from A to B, see, I am moving along with the direction of the current. So when I am moving from A to B, okay, so the product of current and resistance will be taken as positive. Similarly, if I am moving from B to A, I am moving against the direction of the current. So the product of current and resistance will be taken as negative. So this is a very, very important rule we must have followed in when we are simplifying the Kirchoff rule. and especially in a closed circuit. Okay, see now, based on this, actually what is that rule? So in the first rule I told you the algebraic sum of total current in a junction is 0. Similarly here in a closed circuit, the algebraic sum of the product of current and resistance is equal to the algebraic sum of EMF in that circuit. So now you can understand why I have used these rules. See, in a closed circuit, I have to be concerned with the product of current and resistance and also the EMF. And the sign is very, very important. Okay, so if I am moving from higher potential to the lower potential, the EMF must be taken as negative. Lower to higher, the EMF should be taken as positive. And if I am moving along the direction of the current, the product of current and resistance must be positive, and the product of current and resistance, if I am moving against the direction of current, will be taken as negative. Okay, so based on this, so let us check a closed circuit. Yeah, see, let us consider an example of this circuit. Remember, now I am going to use the Kirchoff second rule. First, I told you the rule. It is the algebraic sum of the product of current and resistance in a closed circuit is equal to the algebraic sum of the EMF in that circuit. See, let us consider A, B, C, D, E, F, A. It's a closed circuit. I can take two closed circuits. One is A, B, C, F, A. Another one is F, C, D, E, F. Or the whole. Okay. So it is our convenient. So if the battery, its EMF will be taken as E1 and its EMF will be taken as E2, and this is R1 and this is R2 and this is R3. First I have to notify the direction of the current. See, always current is moving, starts from positive and terminates at negative. So here will be the direction of the current. And for this battery, this will be the direction of the current. Okay, so the current will be moving towards in, and at the junction it has to be moving in, and here it is a negative terminal, so it must be moving towards this junction. Even here it must be coming from here, and it should be moving there. Okay, and so here it is coming and it will be moving there because it has to reach us the negative junction. Okay, right. So now I am just going to give the name of the current. This is I1 and this will be I2 and this will be, let us take I3, or let us take here. So this will be I3. Okay, right. Now let us take the closed circuit A, B, C, F, A. In that closed circuit, okay, I am going to apply the Kirchoff second rule. And that's a rule. So I know that it is the product of current and resistance. I have to check the direction of the current also. See, when I am moving from A to B, I am moving along the direction of the current. So the current is I1, the resistance is R1. So it has to be considered as positive. So I1 R1. Then I have to move from B to C. It doesn't have any component. So when I move from C to F, I have a current I2 and also the resistance R2. So I am moving along the direction of the current. So it will be taken as positive. So I2 R2. Okay. Then, so I have to move, it must be equal to the EMF. Here the EMF, the battery I have, it is E1. See, when I am moving from A to B, I am moving from lower potential to the higher potential. So it will be taken as positive, that is E1. Similarly, suppose if I am taking another one closed circuit, that is F, C, D, E, F. In this closed circuit, see, the rule is same. If I am moving from F to C, see, I am moving against the direction of the current. So I2 R2 must be taken as negative, minus I2 R2. Then from C to D, it doesn't have any component, and moving from D to E, I am moving along the direction of the current. So that will be equal to plus I3 R3 will be equal to. So when I am moving from D to E, okay, the potential will be lower to the higher. So will be equal to positive E2. That's it. Actually, our aim is to measure the value of I1, I2 and I3. Okay. See, let us take the junction anyone, either F or C. Okay. So for my convenience, I am just take a junction F. Okay, at F. See Kirchoff first rule. According to Kirchoff first rule, the current moving towards the junction is positive, moving away from the junction is negative. Okay. See here I1 is moving. Yeah, I1 is moving out, I2 is moving in, I3 is moving in. So I1 will be equal to I2 plus I3. I1 is equal to I2 plus I3. Okay, by substituting this value, okay, we can solve the amount of current and also the amount of the EMF which is available there. Okay, Kirchoff rule can be used in those circuits. Okay, if you like this video, like, subscribe and share. Thank you.